So today we're doing a few different types of problems, which we will work on more tomorrow. I won't be teaching anything tomorrow, obviously, because in 15-minute classes, what can I really do? But you'll have class time to keep on working on your assignment. So that's what we'll do. We'll just keep on working. So I want you to convert 82 inches into yards. How do you do that? Divide by 36. Interesting. And then I heard 3.
Oh, yeah. I was thinking of 3 feet.
Oh, okay. So I'm hearing a lot of different things. So 82 inches, right? And then I want to convert it into yards. And so I'm going to do what now?
Divide by 3.
Divide it by 3. So you're telling me to divide by, why would I divide it by 3?
Feet there.
You can, okay, so you want to turn it into feet.
Yeah.
Huh, okay.
Well, no, because then you talked about if you divide it by 4.
So there's lots of ways to do this, right? Okay, so I'm hearing that you know the conversion that
Times it by 1/12 and by 1/3.
1/12 and 1/3. Okay.
Because there's 12 inches in a foot and then 3 feet in a yard.
Okay, so you said there's 12 inches is equal to 1 foot. All right, that's a conversion factor. Okay. Well, so I want to talk about this because I heard something from the science department that was just really, really terrible. When we're converting, we're actually just multiplying fractions. Okay? Yeah, you are. And it's unit cancellation, which hopefully you guys all do in chemistry. All right? And it is just converting units. And so what we have here are 2 equivalent measurements. They're equal to one another. And so there's, again, lots of ways we can do this, but I liked Noelle's explanation. It was good. I want to do this because what I can do is I'm allowed to multiply fractions. I'm allowed to multiply by the equivalent of 1. And so when I multiply by 1 foot over 12 inches, did I change the value of what I started with? No, because 1 foot is exactly equal to 12 inches. They are equivalent measurements, so it's essentially multiplying by 1, right? So I just want to make...
Are we just doing this?
No, we're not doing this, really. But
No, I know. Are we?
So, and then Noelle said that 1 yard is equal to 3 feet. And so we can do the same thing because now what happens is when we multiply our fractions, when we have inches on top and inches on bottom, they cancel one another out. And so now I need to cancel out my feet and turn them into yards. So I'm going to multiply by another equivalent fraction of 1 yard is the same as 3 feet. And so again, now my feet on top and feet on bottom cancel out, and I'm left with units of yards, which turns out to be exactly what Trinity said, which was take 82 and then divide it by 36 because there are 36 inches in a yard. Okay. But really, so how many times is 36 going to 82? 2. What, 36 times 2? Got it. 36 times 2 is 72. Okay. So how many inches are left?
2.7.
10. Yeah.
Oh, you want to do it like that?
Which reduces to
0.7.
okay, 5/18. Okay. Well, it would be, yes, but okay. So So all I'm doing here is refreshing your brain about canceling units, which hopefully you know how to do because the next problem, canceling units, is what we're doing. No, you don't need to write it all down. So we'll just read it together. Please write example 1 and you don't need to write it down. It is in your book if you want to take a picture. You can. An orchard contains 60 trees all planted in rows. The number of trees per row is 8 less than 3 times the number of rows, which is really weird wording. Find the number of rows and the number of trees per row. Really weird. You really like this question, but I couldn't not do it. Mostly because they have a question kind of like this in college algebra at U of A. So I thought I needed to do it. Okay, so first of all, they told me something that this orchard has 60 trees. Okay, so, and then what we're trying to do is find the number of rows and the number of trees per row. Well, trees per row is a fraction. And so when I read trees per row, I actually think that I convert it to a math statement. Trees per row. And if I multiply trees per row times a number of rows, what happens? The rows cancel out and you get trees, right? Okay, it's kind of interesting, right? So just by thinking about the units, which is what these are, it really, really can help me out here. So it says the number of trees per row is 8 less than 3 times the number of rows. Well, that's kind of a big old mathematical statement. It says the number of trees per row, I'm gonna write that down, number of trees per row equals 8 less than 3 times the number of rows. What can I write for that? Yeah, okay, 3R. So you're saying number of rows we're going to call R? Okay, cool, that works. 3R minus 8. All right, so R equals the number of rows. Does that make sense to you? Okay. And so I can sort of substitute that in here. Trees per row is the same as 3R minus 8. And what's our number of rows? R. Equals number of trees. How many trees? Oh, 60. Yeah. Okay. All right, so what should I do with that times by R? Distribute it. All right, so 3R times R is 3R squared minus 8R equals 60. And we can solve. How are we going to solve?
Move the 60 over.
Move the 60. So 3R squared minus 8R minus 60 equals 0. And then we can double bubble. Let's see. 3R times R would give me 3R squared. What times what is going to give me negative 60? There's so many. 6 times 10. Negative 5 times 12. Negative 4 times 15. All right, I'm trying to get an 8.
Oh wait, no.
Oh, it was the first one. All right. Here, let's put the -6 on the outside and the +10 on the inside. How do I know if I did it right?
Check the ring.
Thank you. Check the rainbow. When I check the rainbow, I'm getting -18R and a +10R. And that's where that middle term comes from. All right. And so then I can set each bubble equal to 0. So 3R plus 10 equals 0 and R minus 6 equals 0. So I get R equals 6 and I get R equals -10/3. Does that work? Can you have negative rows of trees? That would be some weird space-time continuum there. I don't think so. So we get 6 rows because that's just ridiculous. All right, so it says find the number of rows. There are 6 rows and the number of trees per row. How are we going to figure out the number of trees per row?
6 divided by 6.
Oh, that's very smart. Is it 60 divided by 3? No, 60 divided by 6. Yeah, it is 60 divided by 6. There are 10 trees per row. So you can just divide trees by the number of rows, and that'll give you trees per row. Or you could also plug it in here. 3 times 6 is 18, minus 8 is 10. Okay, so a couple of ways to figure that out. All right, questions on that one? That's all right? Good. Okay. Look at another one. Did I? All right, again, there's a problem like this in your book. So if you wanted to take a picture, you could, but we'll just do the math together. Okay. So example 2, make sure you write the example 2. You don't have to write all the words though. All right, Eric and Dalton start at the same location at the same time and drive their cars in opposite directions. These guys have a lot of time on their hands, I guess. Drive their cars in opposite directions for 5 hours. At which time they are now 590 miles apart. So the first thing I'm going to do is I want to have a nice little picture. So I'm going to say this is where Eric and Dalton are starting. And they're driving in their cars from the same point, and they start at the same time. That's really important. And they're driving in opposite directions. So I'm going to say that Eric is driving this way, big E for Eric, and Dalton is driving this way. And after how much time? Okay, so after 5 hours, they are now 590 miles apart. $590 miles apart in 5 hours. All right. If Eric drives 2 miles per hour faster than Dalton, find the rate of each driver. First of all, find the rate of each driver. What is rate? What are they talking about? Miles per hour. Yeah, definitely miles per hour. So, speed. Good. Okay. What do you know about distance and rate and time? Okay, let me ask you another question. If I'm driving 60 miles per hour for 2 hours, how far did I go? 120 miles. 60 miles per hour, 60 miles every hour for 2 hours gives me 120 miles, right? What's happening with, whoa, oh, did you see that? Did it freeze on? Okay, sorry. My hand was like a still frame. Like, okay.
It's an out of body experience.
I guess. Okay. What happened to the hours?
Cancel.
They cancel and they leave us with miles, right? Okay. And if we were going, okay, 50 miles per hour, and we drove for 3 hours, how far did I go? 150. Okay, very good. So if you know the rate and the time, what is that going to give you?
90 miles.
Distance. Rate times time equals distance. Or more commonly known, distance equals rate times time. Okay, how many of you have heard that before? Because that's what I was looking for. Oh, okay.
Speed times.
Okay. Oh, speed times time? Distance equals rate times time. Okay. Let's see. What else do we know? It says Eric drives 2 miles per hour faster than Dalton. Do we know how fast Dalton drives? No. Okay. So let's see. I always do these things, but I guess I'm not going to. All right. I don't know how fast Dalton goes. I'm going to let D equal Dalton's speed, his rate. Okay. All right. So what's Eric's rate then? Oh, D plus 2. Very good. Okay. So we have a total distance, right? What do you think we should do here? What are you thinking? I should have done this problem.
Is it multiplication?
It'll be D plus 2. Wait. Okay, how about this? D plus 2 plus D times all times 5 equals 590.
Oh my goodness. We have a total distance of 590 miles. How many hours did Eric drive for? Oh, for 5 hours. Okay, sorry. I had a big brain fart here. 4 or 5 hours. And how much time did Dalton drive for? 5 hours. Okay. So if we know that rate times time is going to equal distance, let's figure out the distance that Eric went. So how am I going to find Eric's distance? D plus 2 times the 5 hours. That's going to give me just Eric's distance. Now, how do I find Dalton's distance? 5 times it, yeah. And what are we going to do to their two distances? Add them together, and what are they going to equal? Oh, 590. So we're adding Dalton's distance. He went D miles per hour for 5 hours, so 5D. So when we find Eric's total distance and Dalton's total distance, we can add them together for a total of 590 miles, and that's a D. Sorry, that was a huge brain fart on my part. I was reading it wrong. I'm going to go ahead and distribute my 5. So 5D plus 10 plus another 5D equals 590. 10D plus 10 equals 590. I'm going to subtract the 10 and divide. So D is for Dalton. What is 58 representing?
The rate.
Miles per hour. Yeah, his rate. So Dalton's, find the rate of each driver. Dalton drove at 58 miles per hour, grandma speed. And Eric drove at what?
60.
At 60. How'd you get 60?
Add 2.
Added 2. Yeah, Eric's speed was Dalton's plus 2. So 58 plus 2. All right. Phew, that was crazy. The next one is worse. We're not done yet. I have a lot today.
You do? Is that it? How many are there? Oh my god.
Wait, there's. Okay, Chris, I'm gonna flip one.
All right.
I want to say that was a slow-mo drama.
Yeah. This one's quite tricky, I think. Example 3. Riding on a motorcycle, Zach takes 3 hours less time to travel 120 miles than Josh takes to travel 270 miles. Zach travels 6 miles per hour faster than Josh. Find the time and rates of both boys. There's a lot going on in this problem. No. Okay, so one method that I really like doing is making a chart. Rate times time equals distance. And what I have here are 2 key players. I have Zach and I have Josh. Because evidently girls don't drive motorcycles. My husband I met him and he rode a motorcycle. He had a Harley. And then he traded it in and got this.
Oh, smash.
Wow. Okay, yeah, that's worth it.
I cried.
I cried.
Not because he proposed, but because he sold his bike.
Why?
Why'd you sell the motorcycle? Okay. This is pretty hard. Now in your book, they actually show you 2 different ways to solve this problem. I'm just going to show you the one. Zach takes 3 hours less time to travel 120 miles than Josh takes to travel 270 miles. So I know Zach's distance that he goes is 120 miles. And Josh's distance that he goes is 270 miles. And do we know how long it took either of them to go? No, it's 3 hours less than.
So Josh
So-
at least went 3 hours.
Yeah.
-3.
Well, I mean, I don't know. 3 hours less time than it took Josh to go a different distance. And so Zach takes 3 hours less time. Okay, so for Zach's time?
Yeah.
All right. So J minus 3. Sure. And so then J would represent what? Josh's time? Okay, so we're going to let J equal Josh's time to travel. All right, so Zach took 3 hours less time than Josh. So that makes sense. Less time than Josh. Okay. Now, here's the weird part. It says Zach travels 6 miles per hour faster than Josh. I'm just going to write that right here. Zach travels 6 miles. Zach's rate. I'm going to write the rate.
Isn't 6 plus 2 Zach's?
Yeah, I don't think I want to do so many. This is why this one is so weird. This is why I was hesitant to do today. Zach's rate is 6 miles per hour faster than Josh. So Josh's rate plus 6. So here's what I can do. I know that rate times time equals distance. And I have this equation where I'm talking about the rates of each person. I want to get rate by itself. What do I need to do to get the rate by itself? Divide the time, sure. So I can divide by t all day and night. So to get the rate, I can always do distance divided by time. So I'm going to do that here. Zach's rate is distance divided by time, 120 divided by j minus 3. Does that make sense to you? Kind of ish. It's weird.
Is there anything like this on the homework?
Yes.
You know it's gonna be hard. You know it's gonna be 12.
What's Josh's rate? 270 divided by j. And then we know it's plus 6.
Plus 6. Plus 6 on top or just plus 6?
It's just
Just like
plus
that.
6 and 10.
So this is what we did yesterday. Common denominators.
Love that.
All right. I know I can't factor j minus 3, and j is also its own little factor. So I'm going to do just like I did yesterday to clear those fractions.
Wait, is it the 6 miles per hour?
Is it what?
Yeah, I'm confused by the adding this.
Yeah. Plus
Oh.
6. Shouldn't it go with Zach?
Zach travels 6.
Because we already have Zach's rate, don't we? If the 270 we already have Zach's rate, so it'd be 6 on the top for how long he went, like distance, and then under it would be the time.
So the 120 over j minus 3.
Because we don't have a rate for.
Right, that's how we can
Okay.
calculate 3. Yeah. Yeah.
Okay.
All right. So I want to get my common denominator. I'm going to multiply by j, top and bottom here. And j minus 3, top and bottom here. And then what does the 6 need?
It needs. Okay.
Yeah, it needs a j and the j minus 3 multiplied on there. So now that my denominators all match, I get to cross them out, which is the beautiful thing. So 120j equals big numbers, 270j minus 270 times 3, I don't know, 810, minus 810, plus 6j squared, minus 18j. And we're going to set it equal to 0? All right. All right, so I'm going to put my 6j squared first. Goodness gracious. 270j's minus 18j's minus 120j's is 132j's?
Yeah.
And then minus the 810. Those are giant numbers. I hope so. Whoops. 130. Yes, everything divides by 6, so that's super nice.
She lost.
I'm going to divide everything through by 6. J squared, 132 divided by 6 is 22. Okay, thanks. And then 810 divided by 6 is 135. Good grief.